Hello everyone. So today we're going to be talking about the creation of parametric patterns, as many of you have requested that in our survey. So I'm going to show you a couple of methods of how to create quite complex and, in my opinion, interesting 2D patterns with the help of Parametric and Grasshopper. Just a usual reminder that if you'd like to support what me and my colleagues are doing, we have a parametric design market where you can purchase some of our design scripts and also some of the 3D models that we make. And also, if you'd like to organize a consulting or to learn Grasshopper with us, we have the courses indicated on our website. Please find it in the description, and just drop us a message on Instagram or on our email, and we will make sure to help you to learn Grasshopper and Rhinoceros. All right. Having said that, let's start our tutorial. So today I'm gonna start with developing a relatively simple pattern. I'm gonna show you first, so you can have a look. Basically, it looks like this, right? So yeah, basically this pattern is quite simple one in fact, but I think the method of creating it is quite interesting, at least for me. So yeah, let's start. So I'm going to start with creating a square grid. Very simple tool, very simple command. Setting up the size for the grid. I'm going to set it up here. Yeah, so let's say I want to make sure we have some complexity in our pattern. So some let's say large dimensions. So let's make the x and y dimensions quite big. Right, so it's something like that. Maybe a bit wider, something like this, right? Okay, so after that we need to basically start forming our pattern, first of all linearly, right? So we take the points. This is the first thing. Actually, I'm not gonna flatten them, I'm just gonna keep them like this. And also, I'm gonna create a bounding rectangle. This is a component from Pufferfish plugin, which I think is quite a useful one, right? And I'm gonna flatten this so we get just the outline. And then let's just let's turn it into a boundary surface, and let's take the edges from direction. Just from directions this way, right? So I'm gonna take the ones that are parallel to y-axis, right? So this is the direction. 5 degrees is gonna be the tolerance, more or less, right? We take these edges, and basically that's it, right? So we take these two curves, and then I'm gonna start forming this diagonal character of the pattern. So I'm gonna divide this list into two curves, and then I'm gonna say extend. Actually, we can even extend it like that. Extend curve. Yeah, we can, because they are pointing in different directions, so we can just do it like that. And I'm going to extend one direction and not extend the other one. So maybe something like this is better. Yeah, something like that. And then I'm going to say divide curve. I'm going to divide it into a certain amount of points, each of them. I would say let's divide them into 120 points, maybe something like this. And then we're going to say flip last. Also, one more thing. Once we have extended those curves, we still have to flip one of these curves. Right, so we have to make sure they go in the same direction. So let's do it like that. And then once we have it, we just say polyline. So we do polylines through these points, right? So something like this, correct? Okay. Now, also, if we want to increase the angle, I'm gonna increase the extension, so it's getting even more. Let's say 200 should be fine, probably. This, then also maybe, yes, something like this should be fine. Also, I'm going to increase this to 250. Yeah, this one looks good to me. Now it's time for us to actually create the curves that will form this pattern. First, we create this pattern linearly, right? So I want it to be relatively simple, right? So if we look at the lines of this thing, it should be something, well, something like this, right? So this is kind of the pattern we want to achieve at this stage, right? So let's think how can we do it. I think the best strategy here will be to divide each of these curves into a certain amount of segments, right? I'm going to use careless range component for that. So let's say, yeah, say evaluate curve. I'm not using shatter directly so that I can just see how will it be divided, right? So let's say, I don't know, let's say 120 divisions should be fine. Maybe a bit too much, but we will see in a bit. Oh yeah, that's probably a bit too much. But no, actually I think it's fine. Right. So we say shatter. We parameterize this curve as well. We shatter it, right? And now our goal is to actually, and then I'm also going to increase the errors a bit. So it's even a bit more random. But now, in fact, our idea is to make sure we have this pattern quite random, but somehow repeating itself, right? So it cannot be completely random. So what we need to do, we need to make sure that the pattern is going to be repeated along these curves, but then we have to shift it, right? So that we get this kind of shift in a way, right? And it should be somehow repetitive. So I think the best strategy for that will be to actually first we create this pattern and then we start shifting we can actually start shifting these curves right away. So we have, let's say we display statistics to find out how many branches we actually have. It's 121. So I would say let's randomly create this shift for the constructor main. Let's see, from I don't know, from 3 to actually the shift can become 0 to 20, let's say, maybe 30. Doesn't really matter at this point. Yeah, and then I would say I want repetition to happen every 12 curves, right? So we get these 12 uh, um, steps, and then we say repeat data, right? And then we use this um, yeah, I would say let's use this as the data to repeat and this as the length, and then we just graph it. So we make sure that our each of our um, each of our curves gets its own value for the shift, right? So then, what is the way to check how it looks? Basically, we need to select the first element, right? And you see, basically, this is kind of the pattern we're getting. This is just the first element, right? So if we make a slider, you see, this is kind of the pattern. Oh, it's actually quite beautiful. I like it. So it's like I can already see how we can create quite a nice animation with this type of pattern, like something like falling water or something like the text in from Matrix, like something like this. It can be nice. All right, so now it's time to actually start grouping our parts together. right? So we want it to be not just one element and then empty and then another one element. We want it to consist. We want all these curves to consist of several um, lines, like short lines, right? So now we need to randomly, but again randomly, but in a way repetitively, we need to make sure that we control this pattern a bit more. So I would say let's start using the dispatch. Let's use dispatch directly right from here. So if we use the default pattern, right, if we just say like yes, no, yes, no, yes, no, we get something like this, right? So it's quite. I mean, I still think it's not bad. It actually looks like some sort of weird line type, which I kind of like to be honest. But yeah, I think we can still do better than this. And I think in order to achieve that, we need to create different lengths for this pattern. So let's say we create something like that. Let's try. So first of all, I want to define the length of the separate parts of this pattern. I would say let's start from 2 and up to 8 segments will be joined together, maybe up to 12. So, yeah, let's say 12 for now. We can always make it bigger or smaller, so it doesn't really matter. And here, for the number of values, I want to say 6, maybe. Right, so something like this. And this all will be duplicating our data, and we will be using 0 for that. In fact, let's also create the thing for false right away. So for false, I want our pattern to be a bit less dense. So I want the false to be bigger than true, right? Something like this maybe. We will see. And now I want to make this thing multi-line, and this thing I will also say with here, right? So, and I'm also going to use integers so that these numbers they will be rounded to form integer numbers, right? Not numbers with decimals. So yeah, let's say something like this, and then yeah, basically mm, will this work? No, actually this doesn't work. I think we need to. One second. So this should be yeah. This we need to create the same amount of branches. So let's say um, let's say I'm gonna make something like this. I'm gonna say duplicate data. Actually, no, not duplicate data, but repeat data. I'm gonna repeat this data this many times. So this pattern will be repeated, right? We get this 0, 1, 0, 1, 0, and so on. And then we duplicate each of these numbers this number of times. Each of these values this number of times, right? So as a result, we're getting something like this. We're getting 96 values, which is fine. And then we can say shift path setting, or even flatten, doesn't really matter. We can simplify this here. Although, in general, simplifying things is not generally the best strategy, but yeah, whatever. Yes, there we go. So you see now we're getting this pattern. In my opinion, at least it's a lot more interesting. Maybe it's a bit too dense, so I would make it a bit less dense by sorry, actually it should be the other way around. It should be like this. Yes. So because the first data set controls the um, length of the gaps, and the second data set controls length of the lines, right? So, and then yeah, of course we can also control the amount of shifting these lists, right? So we get something. This looks pretty cool actually. So yeah, basically with this simple script we can control quite a lot of stuff, quite a lot of things, right? So we can also here we can make the script more reliable because now it's almost completely you can't really see like the pattern here, right? But it's not repetitive. But here it gets a lot more repetitive, and you can actually clearly see this pattern. So this is also another um, amount of control we get here, right? So okay, cool. Basically that's it. Almost. Of course, we also need to take these points, right? These ones, and we need to control them by. Actually, I would also say it might be useful to. It doesn't matter. We're going to use full points, so it's going to count the distance to the closest curve. So we take these points, we connect them to the point input of the full point, and these curves, we're going to connect them to the, we're also going to flatten them, of course. We're going to connect them to the attractors, right? So it's a bit heavy, I think. Sorry, my bad. Actually, there's one more thing we need to do. We need to actually say join curves, right? So we join them, and now instead of almost 4,000 curves, we're getting 850 curves, right? So it's, yeah, and you see the time drops significantly, so it's good. Okay, and now we need to basically say normalize. This component, by the way, comes from Heteroptera plugin, which is also quite a useful one. And then it's very standard. We just take the graph mapper, we take the remap numbers, we take the bounds, we're also taking the construct. Okay. Let's say the size is going to be from 0.25 to some up, so 0.25 to something like 1, maybe 1.2, 1.5, I don't know. Let's just make sure it doesn't look too big. And then it's a circle. So we connect this to radius, and we take the points and connect them to the point, to the center of this circle, actually. Here, this, right? So this is our pattern right now, but we can also change it to make it more contrasting with the help of this year, right? Actually, also, sorry, I forgot to mention. I mean, this also looks pretty cool to me, at least, right? So this is also not bad. But in order to make it look even more interesting, I would start with first with taking out some of the points. Right. So I'm gonna check if the distance from the attractor curve is smaller than let's say, I don't know, 7.5. Then we're just going to eliminate the points, right? So we're going to take it like this. And let's see. So, it seems like we're getting a lot of these points, so maybe we can do it like that. Oh, this also looks pretty cool, I have to say. So we have a lot of options here. And then yeah, then of course, I'm also gonna call the distances here, right? So we get these new points and these new distances. I lock my solver so it doesn't compute too early, and that we can basically connect everything we need. And yeah, now going to yes, so this is already looking a lot better. So let's say yeah, something like this, and um, I think something like that should work better, right? And also, I want to make Yeah, drop this distance even more. Yeah, maybe there are too many of these lines. So let's say I'll drop it to something like this. Yes, I think this is a bit better. And then we are getting, yes, now we can actually see these lines. I think this is pretty cool already. And then we say boundary surfaces. We also craft these circles, and we are getting this geometry. So once we apply the custom preview, we're basically able to see this pattern in, especially in edit mode, we can see this pattern, right? And then yeah, then basically by controlling these sliders, we can get different patterns all the way, right? So I'm also gonna change this shift a bit, make it a bit smaller, so we can start seeing some repetition. And up here as well, I'm gonna drop it a bit. I think it should get more emptiness, yes, and a bit more, also a bit more uh, way. Yes, I think this now we start getting this pattern a bit more pronounced, right? So here as well, to make it a bit bigger. Yes, I think now we start to get it, and also we can make it a bit more. Oh no, actually, it doesn't really matter. Fine. Um, yeah, I mean we can play with it, but I think you get the point of the here that with this tool we can basically get quite a lot of these triangle patterns. And yeah, I think this is not bad. So okay, this is cool, and now I wanted to show you one more pattern, which is also quite simple actually, but um, I mean it's simple to make, but once you have it, it looks quite spectacular. So this is pattern number one. I'm gonna keep it and I'm gonna disable it so it doesn't bother us. The next pattern is gonna be super simple, but I still think it's quite cool. So we're gonna start in a very similar manner. We're gonna use the square grid. Also, I'm gonna set the size of this square as 12. The extent of, yeah, let's say we're gonna make 20 by 20 grid, and yeah, and then I'm also gonna make one more rectangle, which is gonna be having this size, right? It's gonna be this one. And yeah, we're basically going to work with this rectangle first. So I want to say, I want to take the discontinuity. I want to take the dispatch. So we use points which are located diagonally from one another. So the circle. And let's set the radius as half of this distance. So we divide it by 2. And we connect here. Then, after this, I want to say curve offset. Set curve, right? So let's say it's going to be 1.2, maybe 1.5, something like this. Here we're going to say minus x. Yeah, maybe this is a bit too much, but let's see what we can do. Maybe something like this should be fine. 0.9, perfect. Region difference, right? So it's a bit tricky. So let's say, yeah, I think I have an idea how to solve it. So let's do it a bit differently. Let's say boundary surfaces. Here let's say split surface. surface split. We use these curves to actually flatten them, we use them to split it, and then we say sort list. We take the centers of these split surfaces and we need to sort them. You see they all have different x coordinates, so we say to construct. We take the x coordinate, sort it, and we take the age one, so we say a, right? We take this. Yeah, this is our geometry, basically, right? So now we can group it, and then we can start placing it in these different squares. But I'm gonna rotate all these squares randomly from up to what? This one from 0 degrees, which means it's gonna basically keep its location to 270 degrees, right? And for the number of values, I'm gonna use the least length, and I'm gonna flatten this. So now, basically, we're going to have 400 different rotations, right? To turn to degrees. And we take the center of each of these squares, and we rotate the square around the center. Yeah, but in order to avoid such a thing from happening, we need to say round to factor. I'm not sure if it's a native Grasshopper component or if it comes, no, it comes from Papa Feature, yes. So we take these values and we round it to 90, which means that it's like one 90-degree turn, right? So now we get this thing looking like that everything is not rotating at all. But of course it's not true because now we need to say orient, right? And in the center of each of these rectangles, we should have an xy plane. Actually, we should not be rotating the rectangle, we should be rotating the plane itself. So do it like this, right? Basically rotate the plane around itself, and then here we also need to have one plane, right? So we need to take this original point from here. Sorry, not from here, but you can say construct. No, we need to take the center of the rectangle actually, right? So center, this one rectangle, this plane, and then we say orient, which I have already set here. And now we take this group as geometry, this single xy plane as A plane, as the reference plane, and then these planes as B as starting planes. And now, there we go. Okay? So we're getting this quite a complex pattern in a relatively simple way, and yeah, I think this is quite a nice one. Maybe I'm gonna decrease this number a bit so we can have a bit more freedom to experiment, because yeah, it takes time to compute. So yeah, let's say from 0 to 100, and now there we go. You see we're changing it, and we get this really seamless and relatively complex pattern without almost without any effort. So let's take the custom video here, and yeah, let's make it black as well. Color switch. There we go. So yeah, basically, I would say this is it for today. Um, yeah, I hope it was useful, and yeah, hope you like these tutorials. Please let me know in the comments what you think about these techniques. Also, what would you like to see us making next? And please, if you like our content, don't forget to support us on our parametric design market. And if you'd like to learn the software, drop us a message on Instagram or on our email, and we'll be happy to arrange a session or even a course with you. Thanks, guys.